So these are the last part of our Unit 1 notes packet that I gave you. So we're on part 7, and this is it. It's section 4.3 in your textbook if you're interested in going back and looking at any practice problems to try, or more examples, anything like that. We are skipping this warm-up for today because I want to make sure and get through the notes all today and not have to run into tomorrow. But remember that the links to resources are on It's Learning in the Unit 1 folder. This is one of them. This was going to be like a little matching game to practice with your unit circle and trig. Okay, you can do that on your own time. You can use any of those links anytime to help you study and practice with the unit circle. All right, so what's different in this section, what we're learning that's new, is being able to find trig values at any angle, not just acute angles. Because up to this point, you can see here it says we've restricted our 6 trig functions to positive acute angles. They were all done. We did right triangle trig, all small positive acute angles in right triangles. But now that we've talked about putting angles on the coordinate grid and knowing what standard position is, we can put an angle in standard position. So you can see here in this picture, theta is in standard position, starts at the initial side starts at the positive side of the x-axis, vertex at the origin, and here's the terminal side in quadrant 3. Okay, so that's definitely not an acute angle. Okay, this is greater than 180 degrees, but we want to know sine, cosine, and tangent of that angle. So what we can do is, if we know a point, in this case point P, on that terminal side, we can use that x and y value. You can see they've depicted it here with these dashed lines. Okay, so x is how far over on the x-axis you've gone, and the y is how far down on the y-axis you've gone to get to your point. So the x, y coordinates. We can use those coordinates and the length here of r. Okay, r is standing for radius, so it may help make more sense if you see it with the radius of a circle. So say that there's a circle centered at the origin, and that point P is on the circle, and then that radius, that length, as well as the xy coordinates, we can use those 3 pieces to give our trig ratios. They correspond to what we've done up to this point with like O, A, and H. Okay, so I'm going to try and kind of give you a little picture of that. Just going to draw this angle in quadrant 3 that's there. I'll try that again. Okay, so if I were to create a triangle from here with that radius as the hypotenuse, you can see this would be the x value, how far I'm going along the x-axis. This would be the y value, and this would be the radius. If you want to see how that compares to O, A, and H, opposite, adjacent, and hypotenuse, we're using that reference angle there from the terminal side to the x-axis. It's the central angle in there at the origin. You could think of this as opposite, adjacent, and hypotenuse. And you can see sine is O over H. So it's y over r. And you can see sine of theta is y over r. Cosine is A over H. So x over r. Okay, and tangent is O over A, so y over x. So you can see how it corresponds to O, A, and H, if that helps it make more sense to you. But also think about when we were on the unit circle, we said that the x, y value of any point on the unit circle corresponded to cosine and sine. X was cosine, y was sine. And if you think about that, that's true in this as well. But the unit circle had a radius of what? What was the radius of the unit circle? 1. So if I plugged in a 1 for my r, this is saying sine of theta is y. Cosine of theta is x. Okay, so when it's on the unit circle, r is 1, and that's why y is sine, x is cosine. But when we're not on the unit circle, there's some other r value besides 1, we have to be sure and put that as part of the ratio. Okay, tangent doesn't change. Tangent is still y divided by x, or sine divided by cosine. Y'all follow that? And then, of course, you have the reciprocal functions. You just flip those fractions. Okay, so that was on the worksheet that I gave you Tuesday. I think on the bottom question, it was asking you to give your ratios in terms of OA and H and in terms of X, Y, and R. This is what it's referring to, X, Y, and R here, these ratios. All right, now, if we are given the coordinates of that point, some random point on the terminal side of the angle, okay, here are the steps we're going to use to find all of the trig functions. Okay, step one is to make sure that you're in the correct quadrant. Okay, so plot your point in the correct quadrant. And remember how you know where you're going to be. You've been plotting points a long time. Remember, if it's positive, positive, you're in quadrant 1. Okay, if you've got negative, positive, you're in 2. Negative, negative, you're in 3. And positive, negative, for your ordered pair, you're in 4. So figure out what quadrant you're in, and we're going to draw the terminal side to that point. Okay, so plot the point, draw the terminal side. Okay, so with example 1, I'm going to do that first. Okay, so 8, negative 6. So positive, negative, quadrant 4. So I'm going to sketch the XY axis just this much to show quadrant 4. And then I'm going to draw the terminal side of my angle to that point, 8, negative 6. So I'm going to plot the point, 8, negative 6, here-ish. Okay, and then I'm going to draw the terminal side to that point. That's step 1. Step 2 is then to create the right triangle using that terminal side as the hypotenuse. So I'm going to go over and down. The X and the Y value create the right triangle. So that's X, that's Y, and this is R. And the points actually were 8, negative 6. So I went over 8, down 6, okay, to create this triangle. Step 3 is then to use Pythagorean theorem to find the missing hypotenuse. Okay, so Pythagorean theorem is a squared plus b squared equals c squared. I know both legs. You can plug in just the number. You don't need to worry about the negative, because when we square 6, we get the same thing as squaring negative 6, right? Because when you square a negative, it comes out positive. So you really don't have to worry about the negative of those legs when you're doing Pythagorean theorem. Okay, so 8 squared plus 6 squared, and I'm going to go ahead and write that as R. My pen is writing all these random lines. It's driving me nuts today. All right, so we've got 64 and 36. That is 100. How do I get rid of the squared to solve for R? Square root. So the square root of 100 is? The square root of 100 is 10. Thank you. Again, another random line. Okay, so this is 10. So now I have all 3 sides, X, Y, and R, and I'm ready to do step 4, which is to use those lengths, X, Y, and R, to give our 6 trig ratios. Okay, so I'm going to write out the 6 trig ratios: sine, cosine, tangent. I'm going to start with those 3, get those done, and then I'll do the reciprocals. If it is helpful to you to write the ratios just off to the side until you get the hang of it, you can. Sine is y over r, cosine is x over r, and tangent is y over x. Drives me nuts that it puts these extra things in here and makes my handwriting look sloppy. All right, so sine is y over r. So that's -6 over 10. We can reduce, so we reduce. That is -3 over 5. Okay, cosine is x over r. That's 8 over 10. Also, that reduces to 4 over 5. And then tangent is y over x, so -6 over 8 reduces to -3 over 4. Now we'll give the reciprocal functions. So the reciprocal of sine is cosecant. So when I flip that, it's -5/3. The reciprocal of cosine is secant. When I flip that, it's 5/4. And the reciprocal of tangent is cotangent. That becomes -4/3. So there are all 6 trig ratios. That's what we were asked to give. Double check, go through. Double check the signs, SIGN signs, by knowing what quadrant you're in, by quadrant. So that's the all students take calculus. You remember that little mnemonic? All students take calculus. That's telling you which trig function is positive in which quadrant. So in quadrant 1, they're all positive. In 2, sine is positive. In 3, tangent is positive. And in 4, cosine is positive. The other 2 are negative. Okay, and then the reciprocals keep the sign that their reciprocal has. So we were in quadrant 4, so cosine should be positive, which it came out to, so that's good. The other 2 came out negative, so it checks out. So just make a quick double check that your positive or negative signs are correct. All right, so number 2 is very similar. Okay, I want y'all to give it a shot, a 4-step process. If you're watching this on video, you can just pause, work it out, and then fast forward to where I go over it. Okay, but y'all in class, I'm gonna we're just gonna do a 2-minute timer. Okay, 2 minutes, see how far you can get. If maybe you can at least get the picture drawn, maybe the Pythagorean theorem done. Okay, but let's see what you do. All right, that's 2 minutes. Let's see how far y'all were able to get. what quadrant, let me unfreeze y'all's screen here so you can see what I started with. All right, so you should have gotten that this point negative is in quadrant 3. So here's the sketch I did of the triangle. So my terminal side goes to the point -2, -1. So the x is -2, the y is -1. I need to find r. So my Pythagorean theorem here, this is 2 squared plus 1 squared is r squared. That comes out to 5. I have to take the square root. So I have square root of 5. And I leave it as the radical. We're not giving decimals here. Okay, so now I'm ready to give my ratios. So again, if you want to jot them down, sine is y over r, cosine is x over r, and tangent is y over x. Okay, so what is sine's ratio? What over what? -1 over radical 5, or square root of 5. Do we leave it that way? No, we don't leave radicals in the denominator. What's it called that we do? Rationalize. Okay, so to remember to rationalize, another review of rationalizing. We've done this, I think, in almost all parts of our notes. There's been one we had to rationalize. We multiply by the radical, the square root down here that we're trying to get rid of. And what we do to the denominator, we do to the numerator. Okay, so when we multiply straight across, that's negative square root of 5. You can't tell that that's a negative. Touching. So negative square root of 5 over, and then the whole point in multiplying a radical by itself is to drop that radical, and it's just 5. Okay, what about cosine? So I have to do the same process of rationalizing. Once you get the hang of rationalizing, you do not need to show me this times root 5, times root 5. You can go straight from -1 over root 5 equals negative root 5 over 5, okay? If that makes sense to you, okay? If it helps you to write out the work every time, that's fine too. Doesn't hurt to have more work. So it's -2 root 5 over 5. And then tangent, y over x. So what happens when you have a negative divided by a negative? So that's actually positive 1/2, right? So then when I do the reciprocals, I have already rationalized this. Don't flip a rationalized answer, because then you're putting the radical back in the denominator and you have to re-rationalize and reduce. Go back here where we originally wrote it, flip this. So it's just going to be negative root 5, because the 1 goes to the denominator. You don't have to have a 1 as a denominator. That's understood. You can just write it as negative square root of 5. If you want to put over 1, that's fine. It's just not necessary. All right, so I'm going to go back to the original here. So this is going to be negative root 5 over 2. And what's the reciprocal of 1/2? Just a 2. You can put over 1 if you like. Now let's double check our signs. Quadrant 3, remember, all students take calculus. Quadrant 3, tangent should be positive. Did it come out positive? It did. Did the others come out negative? They did. Okay, so it checks out. All right, so that's one type of problem that you're going to be asked to do. This is actually like number 3 on the worksheet that I gave you Tuesday. So you can do number 3 now, and you should be able to complete that worksheet all the way. All right, now this is a quick little, I actually want to move this down some to give me room to draw above it. So give me just a sec to do that. And wipe this out when he comes back. Okay, sorry, I just needed a little white space above it to write. Okay, so quadrant angles, we said in the previous parts of the notes that quadrant angles, those are your angles when the terminal side is on the X or Y axis, right? So that would be like 0, 90, 180, 270. Y'all agree? So let's think about those 4 points around the unit circle. What were the ordered pairs of these 4 points around the unit circle? What here at 0 degrees, what was it? 1, 0, because I could go over 1, up 0. What about here at 90 degrees? And at 180 degrees? And at 270? Okay, and we said on the unit circle that X and Y correspond to cosine and sine, right? So all of these ordered pairs, this is telling me at 0 degrees, cosine is 1, sine is 0. At 90 degrees, cosine is 0, sine is 1, right? And we actually, on the unit circle, we went around and put the tangent values as well. We said tangent is y divided by x. So 0 divided by 1 is 0. 1 divided by 0, that's undefined. Okay, so just be careful and make sure you remember that dividing by 0 is undefined. Okay, or you can think of it as y divided by x to get the tangents. Okay, so when you are asked to do trig for a quadrant angle, these really should be the easiest ones. So let's look at this. I've got sine at 180 degrees. So here's the 180 degree, oh, nope, negative 180 degrees. We're gonna go this direction. Here's 180 in positive or negative direction, gets you to the same point, right? Okay, sine, we said, is the y. So the y value here is 0. That's it. That's your answer, 0. Okay, now this one wants tangent at 3 pi halves. So remember 3 pi halves, that's 270, that's down here. Now tangent is not the x or the y. Tangent is y divided by x. So we said -1 divided by 0 would be undefined. Okay, good. I'm gonna abbreviate that. All right, now we've got secant at 4 pi. Okay, well, what's a full circle? 2 pi. And so if I did another full circle, wouldn't that be 4 pi? So 4 pi, the terminal side is right back here, the same as the initial side. So you're right back here to this point. Now they are asking for secant. Secant is the reciprocal of cosine. Okay, so I'm asking myself, okay, well, what is cosine at 4 pi? So which one of these is cosine? Which is 1. Well, what's the reciprocal of 1? 1. If you think of it as a fraction, 1 over 1, flip it, still 1 over 1. So that answer is 1. Okay, and then this last one is cosine at 270. We already did 270s, the same point down here. Okay, and this time the last time we did that angle, they wanted tangent. This time we went cosine. And we said cosine is the x value. So it is cosine at 270 is 0. So what you'll notice, it doesn't matter if it's sine, cosine, or tangent, or one of the reciprocal functions. It doesn't matter if it's a positive or a negative angle. Okay, if it's one of the quadrant angles, any trig value will be either 0, 1 or -1, or undefined. Those are the only 4 answers for a quadrant angle trig value. Does that make sense? Okay. Now this next piece right here is actually the steps we're going to follow, a strategy to help you evaluate trig at any angle using reference angles. Okay, so wherever your angle is, so in this example, here's theta, you find your reference angle. So you do need to remember that a reference angle is the distance from the terminal side to the x-axis. You need to remember that it's always to the nearest x-axis. It should always be an acute angle. Okay, so as long as you know quadrant 1, just a quick recap, quadrant 1, if you know 30, 45, and 60, remember that's root 3 over 2, 1/2, root 2 over 2, root 2 over 2, and then 1/2 root 3 over 2. Just know those three are going to help you find angles all the way around because we're going to use reference angles. It also helps to have the tangent memorized for these so that you don't have to actually do sine divided by cosine or y divided by x. So who remembers what the tangent was at 30? Square root of 3 over 3. Remember, 30 starts with 3, has the extra 3. What was tangent at 45? 1. And then the reciprocal of square root of 3 over 3 is just square root of 3. Okay, so if we can remember just those 3, that's going to help us find all sorts of trig values around any angle, not just quadrant 1. Okay, so the process is, what's the reference angle? What's the trig value at that reference angle? So these that we just reviewed. And then what quadrant are you in? Should it be positive or negative? Okay, and that's based off of the all students take calculus reminder. Quadrant 1, everything should be positive. Quadrant 2, just sine. 3 tangent, 4 cosine. So let's try that 3-step process. I'm going to walk you through how I'm thinking as I do these problems. So first, I'm going to graph the angle, draw the terminal side. So 120 degrees. So I start here. This would be 120 degrees. So there is the given angle. So my question is, what's the reference angle here? I'm going to call it alpha. So if I'm at 120, how far to 180? So I have a 60-degree reference angle. So then I'm going to ask myself, okay, what's cosine at 60? Because maybe you don't have these larger angles memorized, but if you memorize quadrant 1, what's cosine at 60 degrees? Cosine's the x at 60. It's 1/2. Right? Here, I just reviewed that with you. This was 30, 45, and 60. So cosine at 60 is 1/2. Okay, then you ask yourself, okay, so I know the answer is going to be 1/2, but should it be positive or negative? I'm in quadrant 2. All students take calculus. Quadrant 2, sine is positive, cosine's negative. So this should be negative 1/2. Does that make sense? Okay, let's do it for B. So 7 pi 6 in radians, half a circle is pi, so that'd be 6 pi 6. So I just go to 7 pi 6. So how far past the x-axis did I just go? What's that reference angle? From 6 pi 6 to 7 pi 6? In radians, that's pi 6. If you want to think of it as 30, that's okay. So that's a pi 6th reference angle. Notice when we're in radians, that angle given, that right there is telling us the reference angle. That's how far from the x-axis. We're measuring in pi 6. So I'm going to, no matter which quadrant I'm in, if my angle that's given is a pi 6, it's going to be a pi 6 away. But you have to know what quadrant you're in to figure out the positive or negative. So I need to know tangent at pi 6, or 30, if you want to think of it as 30, that's the root 3 over 3. I'm in quadrant 4, tangent is positive. So tangent at 7 pi 6 is positive, root 3 over 3. So far, so good? Yes, tangent of pi over 6 is root 3 over 3. That down a little. Okay, and because we're in quadrant 4, it's positive, so it's positive root 3 over 3. So I'll put, so we said this was quadrant 2, this was quadrant 4, so it was negative, or excuse me, positive. This one was quadrant 2, so cosine was negative. All right, let's go through it for part C. 15 pi fourths, that's not even on your unit circle. That's more than a full circle. If we're talking fourths, a full circle is 8 pi fourths. So 2 full circles would be 16 pi fourths. So 15 pi fourths is just shy of that. So that's in quadrant 4. So there's the original angle. My reference angle is just pi fourths. There, pi fourths. Okay, and it's in quadrant 4. So I'm asking myself, okay, what is cosecant at pi fourths? Well, cosecant's the reciprocal of sine. Sine at pi fourths is root 2 over 2. So what is cosecant at pi fourths? But once you rationalize and simplify, remember, it's just square root of 2. Remember, I told you it's going to be a lot easier if you just remember that rule. When a square root of a number is over that number, the reciprocal is the square root of the number. It's just the numerator. Okay, you don't want to have to go through the whole process of flip it, rationalize it, simplify it. Just know it. Okay, so cosecant at pi fourths is root 2, and I am in quadrant 4. So in quadrant 4, should sine, and therefore cosecant, be positive or negative? Negative. So my answer here is negative square root of 2. All right, one more. Negative 135. So I'm going in the negative direction. So this is negative 90. Negative 135 would be here. So you're counting that size of the angle in the negative direction. So there's our angle. So the reference angle, 135 to 180. That's a difference of 45. So the reference angle is 45 degrees. So I'm asking myself, secant at 45, secant is the reciprocal of cosine. Cosine at 45 is root 2 over 2. So what's secant going to be at 45? Just square root of 2. Now I'm going to look and say, okay, I'm in quadrant 3. Should cosine be positive or negative in quadrant 3? Negative. Tangent's the positive one, so cosine is negative. So this is negative square root of 2. You know, kind of think you get the hang of that process. Find the reference angle. What's the trig value at the reference angle? What quadrant am I in? So should it be positive or negative? You okay with that? All right, so the last type of question we're going to look at is similar to the first type we looked at in this part 7, except they don't give us an ordered pair. They're not telling you, hey, there's a point at negative 816. And so we don't immediately know what quadrant we should be in. So the process here is a little different. We have to figure out what quadrant we're in first still. But instead of knowing the coordinates, we know the positive or negative values of two trig functions. Okay, so remember, all students take calculus. Okay, they are telling me by giving me the tangent value of 5/12, that tells me tangent's positive, right? Because that's a positive number. Tangent is positive in 1 and in 3. Those are the two locations where tangent could be positive. So I know it's got to be in 1 or 3. So they give me a second piece of information. They tell me the sine of theta is less than 0. What does less than 0 mean? Negative. If it said greater than 0, that means positive. So they're telling me sine is a negative. Sine is negative in quadrants 3 and 4. So where's the overlap happening? Quadrant 3. That's where tangent's positive and sine is negative. So I know I've got to be in quadrant 3. So that's what's different here than the first one, where they just give you the ordered pair and you plot it into the correct quadrant. We got to think a little bit about our all students take calculus to figure out which quadrant we're in. So now I'm going to draw my triangle in quadrant 3. And I put the terminal side, and then I draw the X, Y, and I'm going to label. Okay, so this is X, this is Y, this is R. Now, I go back to the trig value they gave us. They told us that tangent is 5/12. Well, what's the ratio for tangent in terms of X, Y, and R? Y over X. So they're telling me the Y is 5. And the X is 12. Because I'm in quadrant 3, what do I know about both of those numbers? Say it again. They're both negative. To get to quadrant 3, I had to go left and down. So that's negative, negative. That's why tangent's positive, because the negatives cancel each other out to become a positive. Does that make sense? Okay, so -12, -5. And then now it's just like those examples at the beginning, where I set Pythagorean theorem up to find the missing side. Okay, so 5 squared plus 12 squared equals r squared. Take the square root, and that comes out to 13. Okay, so r is 13. Once you have all 3 of your sides, you can now give your ratios, which that's what it's asking for. Find the exact values of the 5 remaining trig ratios. I'm going to write all 6. One of them is just already given, so it's going to be easy to fill in. So I'm going to do sine, cosine, and tangent. Okay, and I know that sine, or actually I'll go ahead and do tangent, 5/12. That was the given. And if you want, go ahead and do cotangent, because that's the reciprocal of the given. Just flip it. It's 12/5. Done and done. Okay, so now sine is y over r. So -5/13. That does not reduce. Cosine is x over r, so -12/13. That also does not reduce. So then I'm ready for the reciprocal functions, cosecant and secant. So this flipped would be -13/5. And this flipped would be -13/12. So I have all 6 trig functions now. Does that process make sense? So very similar to examples 1 and 2, except for the beginning, where you have to figure out the quadrant and label the sides. But once you've got your triangle drawn and labeled, you're doing the Pythagorean theorem and then setting up your trig ratios. All right, I want y'all to give example 6 a shot, just like you did example 2. I'm going to set that 2-minute timer again and see if you're maybe at least able to figure out what quadrant and maybe get it drawn out. We'll see how you do. If you're watching this on the video, you can pause to do it yourself and then fast forward, however you want to do it. The tangent value came out negative because a negative divided by a negative is a positive. So the tangent is positive here because x is negative and y is negative. Okay. Does that make sense? Okay. Guys, y'all need to be trying this. Try it on your own without the chit chat. I want to see what you can do, not what your neighbor can tell you to do. All right, that's the 2-minute timer. So let's look and see what you got. Let me unfreeze the screen. I can show you what I started with. All right, so I started with my quadrants. All students take calculus. They told me secant, and it's a positive. If secant is positive, that means cosine is positive, right? Because those are the reciprocals. So cosine is positive in 1 and 4. And then they told me tangent is less than 0. That means negative. Tangent is negative in 2 and 4. So the overlap is happening in quadrant 4. So I sketch my triangle in quadrant 4, and I've labeled X, Y, and R. Now, if cosine is X over R, what is secant? R over X. So this number that they're giving us is R over X, but there's no denominator. So I'm going to put an understood 1. So that is R and X. So I'm going to label that on my triangle. X is 1, R is square root of 3. So this one, when I do the Pythagorean theorem, I'm actually not looking for the hypotenuse. I'm looking for one of the legs. Okay, so when I set this up, I'm going to have 1 squared plus y squared equals square root of 3 squared. What happens when you square square root? Yeah, that's just a 3 now. So we've got 1 squared is just 1. So 1 plus y squared equals 3. Move the 1 by subtracting. We've got y squared equals 2. So y is the square root of 2. I'm going to label that in my picture. Now, is it positive or negative? I know when I do Pythagorean theorem, it's coming out positive, but look at what quadrant we're in. How do you know it's negative? Yeah, because it's the y value. In quadrant 4, y is negative. I'm going over and down. That is a negative movement. Now, if you didn't catch that here in your drawing, when you write out your trig functions, remember I said, go back and double check the positive and negative values for your quadrant. So hopefully if you didn't catch it here, when you get your answers and you double check, are these positives and negatives correct? Maybe you would catch it there. Okay, so I want sine, cosine, and tangent, cosecant, secant, and cotangent. I can start with the given. Go ahead and label that as square root of 3. Got one of them knocked out. What is the reciprocal of square root of 3? But once you rationalize, remember, this is one I was saying, just remember it. It's a little easier. Square root of 3 over 3, right? Save you a little work if you can remember that relationship. Okay, now let's do the rest. Okay, so sine is y over r. So that is negative root 2 over root 3. That's a little different. I don't think we have practiced or reviewed rationalizing with a radical in the numerator as well. So let's look at what happens. So when I go to rationalize this, okay, in the denominator, what's happening when you multiply a radical by itself? You're multiplying what's underneath. What's 3 times 3? Times. 3 times 3 is 9. Okay, but they're under a radical. It's radical 9. What's the square root of 9? 3. That's why you're left with just the 3 without the radical. Okay, we just don't show that process every single time. It's like a shortcut. Okay, because you're multiplying the radical by itself, it cancels the radical out, and you're left with the 3. But we do need to know that's what's actually happening, because up here we can't just drop the radical because these two numbers aren't the same. So what is 2 times 3? Well, don't worry about the negative. The negative is just going to be out there in front. 2 times 3 is 6, and that's under the radical. That's not a perfect square, is it? So we just leave it as square root of 6. So it's negative square root of 6 over 3. So when I do the reciprocal of that, it's going to be negative square root of 3 over square root of 2. And when I rationalize, I'm multiplying by the square root of 2 this time. So I still get square root of 6 in my numerator. It's still negative, but my denominator is a 2 this time. Okay, so when you simplify, those don't really look like standard reciprocals that y'all are used to seeing. That looks a little different. All right, and then tangent is y over x, which over x is 1. I don't have to put over 1. I can just leave negative square root of 2. What's the reciprocal of square root of 2? Square root of 2 over 2. Very good. Now double check. I'm in quadrant 4. Cosine should be positive. The others should be negative, and they are. So it checks out. All right, so that's the end of Unit 1 notes. That's all of that Unit 1 notes packet. We're going to be doing some practice with this and some of the things we've already been working on tomorrow. And that homework, that worksheet is due tomorrow at the beginning of class.